Morning everybody. Today we're going to look at something called sigma notation. In fact, most of the rest of the chapter is looking at different types of notation to help us with sequences. So this sigma notation is based around this nice capital sigma that you can see on your screen. It's a Greek letter, and in mathematical terms it simply means to sum. So you're summing lots of things together, adding lots of things together. So this capital sigma will be written, and you'll write one thing below here and one thing above. And these are known as the limits of the sum. So normally what we use is some form of a counter, for want of a better phrase. So for instance we might say r is 1, and we might count up to, let's say, 7. So at the moment this says sum from r is 1 to 7, but that doesn't tell us what to sum. So if I put an r in here, then that will say sum r when r is 1, and then it starts ticking over, and 2, and 3, and 4, and 5, and 6, and 7, and 7 is where we stop. So it's counting through all the integers from where you started to where you finish. And if you add all those together, I don't know what it is, actually it's fairly easy to work out, isn't it? 10, 20, 28 I think. Answers on a postcard. Okay, so that's a really straightforward one. How about if we wanted to do something slightly more spicy than that? Well, what we could do is have r is, let's go for 3 to 5. I don't have to start at 1, I could start at 0 if I wanted to. And let's go for 3r take away 1. Okay, so I'll do the same thing as before, and I just add this term together over and over again, just with the different version of r. So first of all, r is 3. So I've got 3 times 3 take away 1, add. And then I've got r is 4. 3 times 4 take away 1. And then I've got 3 times 5 take away 1. Also, if I work all these out, I've got 8. 4 times 4 take away 1 is 11. So 3 times 4 take away 1 is 11. And 3 times 5 take away 1 is 14. And that is whatever that is, 22, 33 I think. So it's just a compact way of writing writing something which could be quite onerous out quickly. Now, so far I've just added these things up in my head. However, what I could do is use a formula which I've done before, and the way I pick my formula is by thinking about what type of sequence, what type of series I get when I write this out in full. So if I had this one, for instance, r is 1 to 20, I've got 4r plus 1. I could start to write this out. When r is 1, I'm going to get 4 times 1, which is 4 plus 1 is 5. And then I need to add that to 4 times 2 plus 1, which is 9. And I know because this sequence goes up in 4s, it's just 4r plus 1, the nth term 4r plus 1. I can probably from here just actually, because I don't want to write 20 terms out, go right dot 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 plus, and then whatever the last term is. Well, the last term is when r is 20, so that's 4 times 20, which is 80, plus 1 is 81. Okay, so I've got this big old sequence which I want to, so I've got this series made up of the terms of the sequence 4n plus 1, and I want to think about what this is all added together. So I'm adding an arithmetic sequence. It goes up in a constant amount. And so I need to think about what the formula is for an arithmetic series, and I need to think about what things need to go into that formula. Well, I know that I need to know what A, D and N is. A is 5, that's the first term of the sequence. D is 4 because it goes up in 4. And I'm trying to sum together 20 terms. So if I'm going to find out the total for this series, I've got Sn is equal to n over 2, 2a plus n minus 1 d. I can substitute my values in to get 20 over 2, 2 times 5 plus 20 minus 1 times 4, and if I work all this out, I get 10 plus, what's that going to be, 76, isn't it? Which is going to be 860. So far what we've looked at is just the basic idea of how to write something out from sigma notation out into full, and then also, once we've written it out in full, trying to identify is the sequence behind the series a geometric one or is it an arithmetic one. Sometimes it won't be either of those, and you'll just have to manually add them up and hope that actually that's fairly easy to do. Normally there'll be a little trick involved, like for instance if it's something to do with trigonometry, then hopefully you'll get alternating terms, and so you'll be able to see lots of them cancel out. But hopefully most of them end up being arithmetic or geometric, so you can just use the formulas you know. Okay, how about if we went back the other way? How about if we had something like, I don't know, let's go for 5, let's go for something really simple. 5, 10, 20, 40, 80, etc. And let's stop at 80. Okay, so here's my sequence, and let's imagine that it's not actually a sequence, sorry, it's a series. So we've got 5 plus 10 plus 20 plus 40 plus 80, and let's see if we could write this back into sigma notation. So the way to do this is by thinking about what that underlying sequence is in the first place. The underlying sequence is 5, 10, 20, 40, 80. Then thinking about what sort of sequence is it? It's geometric or is it arithmetic? In this case it's geometric, and we know that A is going to be 5. We can see that the common ratio is times by 2, and we can see that n is 5. It's 5 terms, common ratio is 2, the first term is 5. So if I want to write this in sigma notation, I can say that 5 plus 10 plus 20 plus 40 plus 80 is equal to the sum of, okay, so it's the sum of the terms of the sequence. And we know that the general term of an arithmetic sequence is AR to the n minus 1. So I normally write this out in the first instance just so I can think to myself, what am I looking for? And then I just, on the next line, I can fill in the extra bits that I need to. So we know that A is 5, and we know that R is 2, and we know that N is 5. However, I'm not going to substitute that N straight into there, because I'm trying to add up the terms of the sequence. N is the amount of terms in the sequence, and so what I want to do is I want to do it when n is 1, and then I want to do it when n is 2, then when n is 3, etc. I need to have all 5 of those terms in here. So what I'm going to do is I'm not going to use the counter R this time. I've used R for something different. I'm going to use the counter N, and I'm going to start n equals 1, and I'm going to finish at n equals 5, and I'm going to keep my n minus 1 in here. If you're unsure about how that works, just expand this back out here. When n is 1, I get 5 times 2 to the 0, which is just 5. When n is 2, I get 5 times 2 to the 1, which is 10, etc., etc. The important thing to take away is that this does not have to be a fixed letter. It can be whatever letter you need it to be for the particular situation. I think if you look at in your book, on page 77, example 18, they use K. On page 76, they use R. I've used N here. It doesn't matter. It's just whatever you need to change from turn to turn. Okay, so some exercises for you to do today. Can you do exercise 3F? Can you do question 1, 2 and 3 just so you can have a bit of a chance at all those things we've talked about? And can you then try and do 10, 11, 12, which is some past exam questions which are a bit more tough? If you find them particularly tough, give me an email or possibly have a look back at some of the questions from 4 to 9, seeing if any of those will lead in to help you a little bit more understand what's going on. Okay. One last thing. If you're a further maths student, you obviously have other ways of currently doing these sorts of questions. Can you try and use the formulas we've used in this chapter today instead of what we would normally do in further maths, just so you can do both skills? Okay, thanks very much, and I will speak to you again soon. Bye bye.